Sometimes scientists want to use a model of a system in order to study it better. A model is sometimes made of very large objects and taking them and making them smaller. Sometimes, however, a model can be used to take something very small and make it large. What we're going to be working with are large objects like the Earth and the Moon, other planets in our solar system, and maybe even the Sun, and making them smaller so that we can study them in more detail. In order to make models, you first need to set up a ratio to compare the scaled version with the real version. When we do this, the ratio will always have the scaled version divided by the real version. Let's go ahead and read through our example problem together. A model is created of a basketball and hoop. The model basketball is 2.3 centimeters in diameter, and the model basketball hoop is 8.4 centimeters in diameter. If a regulation basketball is 27 centimeters in diameter, how large is a real basketball hoop? Remember here, guys, that we are setting up a ratio of the scaled model to the real thing. In this example, we have a scale model basketball and hoop, and we're working with a real basketball and hoop. Our ratio will look like this. The scaled hoop compared to the real hoop equal to the scaled basketball as compared to the real basketball. These letters would make a lot more sense if we had numbers to go with them. So let's take a look back at our problem and see if we can find any numbers that go with what these letters represent. Capital H here represents the diameter of the model basketball hoop. Take a look back at the problem and see if you can find the number that goes with the model basketball hoop. It's listed right here in the second sentence. This capital B represents the model basketball. See if you can find in the problem the number that goes with the model basketball. It's also listed right here in the second sentence. Our other letters, lowercase h and lowercase b, one of those is going to be our unknown. Let's take a look back at our problem and see what the other number given is. It tells us right here that the diameter of a regulation basketball is 27 centimeters. That's our lowercase b. That means, guys, that this lowercase h is our unknown. Let's go ahead and plug these numbers in. Our capital H, remember, was 8.4 centimeters in diameter, and we are putting that over our unknown. This is equal to the size of our model basketball, 2.3 centimeters in diameter, and we're putting that over the size of a real basketball, 27 centimeters in diameter. Now we have a ratio set up with numbers and one unknown. This is something, guys, that we can work with. Here's the method we're going to use to solve this problem, guys. We are going to cross multiply here. With cross multiplication, you multiply in the shape of a cross or an X. That means that we are first going to multiply 8.4 centimeters times 27 centimeters. That's still equal to the other side cross multiplied, 2.3 centimeters times our unknown, h. we now have numbers in a format that we can work with. Let's take a look first at the left side of the equation. We have two numbers being multiplied here. 8.4 centimeters times 27 centimeters. This is where you can use that handy-dandy calculator. Use either the one on your iPad or a handheld one. Go ahead and multiply those together now. When we multiply those together, we get 226.8 centimeters squared. Our unit is now centimeters squared because we multiplied centimeter times centimeter. The other side is still 2.3 centimeters times h. H is not a number that we can plug into our calculator and multiply. We would, however, like to get h all by itself. Think about how we could do that. In math, when you want to get a number by itself, you need to get rid of anything else that's on that side of the equation. So taking a look here, the only other thing beside h is this 2.3 centimeters. Think about how we could get rid of it. We would simply need to do the opposite operation of what's already happening. Currently, it's being multiplied. What would be the opposite operation here? You're right, it would be dividing. So let's go ahead and divide by 2.3 centimeters. Whatever you do to one side, you must do to the other. When we take 226.8 and divide it by 2.3, we get 98.61 centimeters. Take a look at the other side of our equation. We have 2.3 centimeters divided by 2.3 centimeters. What do you get when you take 2.3 divided by 2.3? You get 1. That leaves us with 1h, which is the same as h. Our answer is 98.61 centimeters equal to h. You can follow this process to solve any kind of scaling problem as long as you remember that you must always put the scale over the real.